All right, so today we're going to continue using some notation that you guys encountered back in 10.2. That notation was that exclamation point, okay? What do we call it? We called it a factorial. And we talked about McKinsey, what that looked like, right? Multiplying the same number all the way down to the number 1 as we do all the natural numbers down from there. All right, so the two different things we're going to encounter in this section are something called permutations, and the other one's called combinations. And I want to give you both of the descriptions for each of them. And then we'll talk about some examples so that you can try to start differentiating between the two. The first one is a permutation. Oh, dear. Okay, there it is. A permutation is the number of arrangements of n things taken r at a time. The key thing that you need to remember with permutations is that the order matters. When you're dealing with a situation where the order of something matters, we're looking at a permutation. Now, there's some notation that we're going to deal with as well for what permutations look like. And the notation that your book uses for this looks like this. Sorry, guys. All right, so the notation sort of looks like that the N and the R are kind of subscripts. They're down like at a lower level than the capital P there that's in between. The P is for permutation. We're going to see another notation that's going to look like this. It's not going to have a P in there. And the formula for finding a permutation is N factorial on top and then N minus R factorial on bottom. And DJ, that almost starts to look like that one you asked me about, doesn't it? But it's missing something too, isn't it? So it's not quite the same as the problem that's underneath our screen up there, but it's close. So I've got N factorial over N minus R factorial. All right, so let me show you the other option. The other option is a combination that we're going to be looking at today. Combination, again, is N things taken R at a time. Okay? But what's that key say at the bottom? The order does not matter. That's the big difference between the two. That's how you're going to make the decision of which one to use when. And the formula, again, looks similar. We've got that small n and the small r on either side. But we've got a c in the middle for combination. That's right. And then the formula for looks similar to that other one. It's got n factorial on top. And it has n minus r factorial. But what else do you think might happen on bottom? Something in front of the parentheses. You just know that because I left a space, don't you? You're really close. It's r factorial. And that's the problem that DJ has underneath my slide right here, underneath my projector screen, right? It had an r factorial in it. So you actually found a combination in your homework from last time. You just didn't know that's what it was doing when you did it. All right, so let's talk about some things where the order matters versus order not mattering before we get to the first example, because I unfortunately, well, the first example where we make the decision, I fortunately threw everybody a little bit for a loop when I just jumped into that one last time. So let me give you a scenario where the order matters versus not mattering, something you've already seen back in section 10.1. So you were asking questions, a couple of you. I think Brian's question was this one over here where I have all the ABCs and whatnot. And we talked about flipping the people around. When did we say we flipped the people around? When we had a position, like a name with a position, right? And when did we not? When it was a committee, okay? So if we were dealing with a committee, we would be dealing with a combination. Order does not matter if we were dealing with a committee, so that would be a combination. If we were dealing with the president, secretary, treasurer, menagerie that we've been looking at, order matters, and we would be using a permutation. Okay, so that's a really classic case of which one you use which place. Another one that I will sometimes give examples of is, let's say you're doing something where people are running a race. You can actually do running a race in either of these scenarios. Okay, so put your thinking caps on and think about the Olympics. Okay, there are two different things that happen during the Olympics. There's the final round where we get the gold, silver medal, but what happens before that? We have preliminary races, right? And in the preliminary races, does it matter if you're first, second, or third in your category or whatever? No, not as long as you make it to the final round, right? So we have this thing where people and the commentators will often talk about them conserving their energy or not working as hard. Same thing happens, right, when you play, so boys, when you play basketball, right? There happens a time when you start putting the people in who maybe aren't quite as good because you need a break. Agreed? This is what people do, right? You conserve some of your energy because it doesn't matter, at least sort of doesn't matter if you blow them out or if you win by 2, if you still win. Agreed? Okay, so let's go back to my race situation then. So if I'm running a race and there's 10 people in the race and it's a qualifying round, that is, top 3 people go on, then does it matter if you're first or second or third? Does it? No. Okay, so Tyler said no. Can I put you on the spot, Tyler? Why is it no?
It's about getting to the final round.
Right, it's about getting to the final round. So if you're third, do you get in?
Yes.
If you're first, do you get in?
Yes.
And if you're second, do you get in?
Yes.
Yes, so does it matter if you're first or you're second or third? No, it doesn't if you're in the qualifying round, right? It doesn't matter, as long as you get, like, you don't want to be fourth. Okay, we don't want to be fourth, I get it. But if we're just taking the top 3, it doesn't matter if I'm first or if I'm third, I still get in.
Oh, okay.
Okay, are we good?
Yeah.
So in the qualifying round, the order of the top 3 people doesn't matter. Now let's go to the final round. Does the order matter of those top 3 people?
Yes.
Yes, because what happens if you're first? You get a gold medal, and what happens if you're third? You get a bronze. It's something different, right? You're still an Olympian, you still get awarded, and it's all still all good. But you get a different medal. There is something different that happens based on your placement. Okay, is everybody kind of following on how you make that decision? Okay, problem number 3 is going to be a little bit different, but let's do a couple of these where we're looking at computations before that. All right, so on problems 1 and 2 here, we've got this new notation. We've got the number before, we've got the P or the C, and then we've got the number afterwards. Everybody good with that? Okay? The number before is always larger or the same size as the number afterwards. The big numbers first, or they're the same size. Those are your 2 choices, okay? The big number at the front, that's my n. That's my numerator. You guys remember those formulas? N factorial was on top on both formulas. Okay, so let's take a look at the first one. What does the numerator become? 12 factorial. What's in the denomination? What's in the denominator of the permutation? The subtraction part, right? Which was, in this one, it's 12 minus 3. So I'm going to write out the 12 minus 3. If you want to jump to 9 without writing 12 minus 3, I'm okay with that. Because that's my next step anyway. I'm going to write 12 factorial over 9 factorial. Is everyone okay with that so far? Okay, now we've done a few of these on the board because you guys were asking some questions about them, right? I'm going to write the 12 out. Where am I going to stop writing? At 9. So I'm going to write out times 11 times 10 times 9 factorial. And in the denominator, it's going to stay 9 factorial. And then what's going to happen? The 9 factorials reduce. They're identical. If we were to write them out, they would identically match. And the nice thing then is all I have is 12 times 11 times 10, which is what value? Thank you, 1,320. Any questions on that? Okay, great. All right, this problem looks almost the same, but it has a C for combination. And the combination formula differs from the permutation formula how? The order does not matter, but how does the formula differ?
It has 2 factorials in the bottom.
Yeah, it has two different factorials in the bottom. And what is the missing factorial right now? R factorial. Okay, so I've still got the 12 factorial on top. What's going to go on bottom? 3 factorial, and then parenthesis with what? 12 minus 3, or 9 factorial on bottom. So I have 12 factorial on top. I have 3 factorial and 9 factorial on bottom. And don't you dare start reducing, because you can't do it when it's in this notation, right? Okay, and how far would I like to write out my 12? Down to 9. So we're going to do 12 times 11 times 10 times 9 factorial. And I've still got a 9 factorial on bottom. What else do I have? Yeah, I'm going to write out that other one. 3 times 2 times 1. Yes?
Why don't you have to write out the 9 factorial, but you have to write out? Is because you have a 9 on the top?
Yes. So you can write it if you want to. It would be okay, Mackenzie, but if you write out the 9 times 8 times 7 times 6 times 5 times 4 times 3 times 1 on top, and you write that all out on bottom, they're all going to reduce.
Okay.
So it's just a notational shorthand. But again, the only time that they can reduce is if they're identically matching. I don't have anything that says 3 factorial on top, so there's no identical match, so I'm going to write it out.
Okay.
But everything in the 3 factorial will reduce, right? So, and this was, because you had a question of how I reduce, I've got lots of choices here. So let me reduce my 9 factorials first. What could I reduce in the denominator? All right, 3 and 12. I'm going to do it one at a time. 3 could reduce with 12, and the 12 becomes a 4. How about my 2? I could do 10 and 2, or I could do 4 and 2. And it's not going to make any difference. I'm going to say my answer. So I heard you guys tell me 10 and 2 first, so that's what I'm going to do. So the 10 is going to become a what? A 5. So this is where you want to keep track of all your little things that are floating around here with your handwriting. Here's a 4, an 11, and a 5. So I have 4 times 11 times 5. You don't have to write the 4, 11, 5 out, but just want to make sure everybody sees the pieces we've got. What is 4 times 11 times 5? 220. So take a look at this. The same 12 objects, the 12 at the beginning, right here and here, the same 3 objects here and here. And what can you say about comparing the permutations versus the combinations?
Bigger.
Which one's bigger?
Permutation.
Permutations, there's more permutations than there are combinations, right? Now, that should make sense, Brian, because of the same thing you did over here, right? When you didn't have to switch the order of things around, what happened? There were fewer of them, right? You guys with me? Now, there are a few instances where you'll have the same number of items in permutation and combination count. Those are sort of some oddball examples. They're limited applicability, but it occasionally happened. But you would not have it reversed. Okay? Permutations is always at least as big as the combinations or bigger. Okay. We're going to try my example. I'm going to proceed with trepidation because it didn't go so well yesterday. We'll see how it goes. We have a contractor. That means somebody who builds homes. He has 8 different models. Okay, so let's like saying he has different blueprints. 8 different blueprints of houses. And presently he has 5 different lots of land to build on. Okay, are you with me so far? He's going to build 5 houses. He's got 8 designs to choose from. Okay, everybody good? In how many ways can he arrange the homes on the lots and build 5 different models? So I hesitate to ask, but does the order matter? Matthew? So Matthew says that the order matters.
Because he wants different models.
He does want different models, but he can get different models with a combination.
I was just kidding.
But it doesn't
No, don't kid.
It doesn't matter which model he puts on which lot.
Are you sure?
Well, there's 5 different models, but each model has to be on a different lot.
Okay.
So it doesn't matter what the model is, but it does matter where it goes.
So let's imagine that he has in the bag, the 5 different names, like a drawing. Okay, he puts the name, he gives them each a name, fun names. This is I don't know, the big house, and this one's the tiny house, and this one's the house with only 3 bathrooms, or whatever, okay? Puts them all in a hat, and he pulls them out. Once he pulls out his 5 different kinds of models, the question is, does it matter where he puts each house?
No. As long as he has 5 houses.
Are you sure? There's zoning laws. I like that, Clinton. That's a good point. What if one of his lots is in Oklahoma City, and one of them is in Edmond, one of them's in Shawnee, one's in Tecumseh, and one's in Norman? Does it matter where he puts those houses?
No.
So what if he has a 4,000 square foot house, which, by the way, if you don't know, that's really big. 4,000 square feet would be a lot of square feet. What if he has a 4,000 square foot house and he puts it next to a little rinky-dink, 600 square foot house, and on the other side there's a 1,000 square foot house. He puts it right in there, squished in the middle of the lot. He may have some zoning issues, Clinton, but what if he can?
Sounds good. His name would probably totally lower than that house sitting at.
I would agree.
Probably have no yard.
Might have no yard, and that may or may not be a good thing, right? What if one of these lots happens to be on the highway? Is that good? Like really close to the highway.
I mean,
Some people would like that. Like who might like that, Mackenzie?
I don't think I would like
You don't like that.
But some people like in this city.
A trucker would like that. Okay, maybe. Somebody who maybe needs access to the highway would like that. Agreed? The highway patrol. All right, that would be okay. Okay, so my point being in all of this, that there's a lot of considerations whenever he's trying to sell these houses, right? Does it matter where he puts each house? Yeah, it makes a difference, right?
But since it doesn't state that stuff, can you just assume that it's like a blanket and everything's going to work out? It doesn't say.
Okay, now let's get the other scenario. Let's say that he has the 5 lots of land and they're all in a row. Okay, they're all right beside each other. Nice and neat right beside each other. And they're all different homes. They all look different, okay? Would the order make any difference? Would the neighborhood look different if he switched up the order? Yes. It would, wouldn't it?
Yeah.
So does the order make a difference?
Yes.
Maybe not a substantial difference in who could purchase it, but it would make a difference in how it looked, right? It would be different if he chose to put house number 1 in first location or in 5th location. And what happens if one of them ends up being on the cul-de-sac or one of them ends up being on an end lot? Could somebody still make the decision then I don't really want one neighbor or 2 neighbors or that neighbor or this neighbor? Yeah. It would matter that they might not choose to purchase that house even if they liked it if it was on an end lot.
Different house, it wouldn't matter.
It might not. It depends, right? So, okay, so what I want you to start thinking about in this, what I'm trying to draw your attention to is that it would change things. Now, whether it changes it enough that somebody would or wouldn't purchase the house really isn't the point. But it would look different. It would change it. The order would be different. It would be a different arrangement if he put it in a different way. Agreed? So the order does matter on this problem. And I wanted you to see this particular problem in here because I want you to get in the habit of asking yourself the kind of questions of whether or not order matters. If I switch things up, will it change it? I have another class right now, and they're trying to come up with permutation problems, like for potential students down the road. And I had a student who had given an example of pulling cookies from a cookie jar. Okay? Would it matter what order she pulls her 3 cookies from her 10 cookies in the cookie jar? That's a great question, and that's exactly what I asked her. Good job, Matthew. Are they the same kind of cookie? And even if they aren't the same kind of cookie, do I really care? The size could matter. That's true, too. Okay, so there's lots of things you have to ask yourself of whether the order matters. Okay, so are we kind of thinking along the right ideas with the problem now? This, well, it depends. I was telling her she'd have to have a lot of conditions on there before it would matter.
Exactly. So
But she has to be explicit. This one's talking about the lots of land.
So she said it's a cookie jar full of chocolate chip cookies, then the order would matter.
Right.
So,
Exactly.
Speaking on a committee, does it matter?
On the committee, it doesn't matter.
But people don't
But that's just a different committee. That you go back to what we're saying. What happens is if you're on the committee versus being off. If there's 3 people on the committee, they're all on the committee. It doesn't matter if I was elected first or last. Like my running example, you're still on there. What's that?
Or if it functions with last committee.
But that's not the question. The question is how many committees could I create?
Okay.
In other words, the committee that is Alan, David, Kathy is the same whether it's Alan, David, Kathy or Kathy, David, Alan or whatever. It's the same
Why
committee.
does that matter for this
Okay.
one?
But not this one.
Because this is just a number of people. What am I going to do? Put them in an order and say now move around? In fact, if there's a circle of 3 people, that wouldn't work anyway.
Okay.
Yes.
Okay, so he has 5 blocks to build on.
We're going to take about 2 seconds longer on this problem. Yes, Tyler.
He has 5 blocks to build on. It has 8 different models.
Yes.
But if he's already given them 8 different models, that means each model is applicable to any lot, right?
Not necessarily. I mean, it doesn't say that, right?
So why bother to choose from 8 models if not all of them work?
They may at least fix the zoning issues that Clinton brought up, right? But just because it fits on the lot doesn't mean it would be appropriate to put on that place. Have you guys ever seen pieces of property that have an inappropriately placed home? I have.
Yeah, there's this one that's like this big and it's like.
It happens. All right, so can we be okay with order mattering? You guys are going to get to practice more of these, I promise. We're going to have to be okay with the order matters here. Order matters. No, it matters. All right, so is it a combination or permutation then? It's a permutation. We don't usually get this much discussion in math class, do we? How many are we selecting from?
8.
8, so the 8 comes first. How many are we selecting? 5. Good. Okay, so I'm going to write this out. What's it going to look like? What's on top?
8 factorial.
8 factorial on top. What's on bottom?
8 minus 5.
Right. So what is 8 minus 5? That's 3. So I have 8 factorial over 3 factorial. So I'm going to write my 8 down until I get to 3. So 8 times 7 times 6 times 5 times 4 times 3 factorial, at which point it actually matches my 3 factorial on bottom. Less reducing to do with the permutation, right? My 3 factorials cancel, and somebody's going to grab a legitimate calculator, not a phone calculator. 6,700, what was it? 20. So there are 6,720 different possibilities here. Matthew first.
About whether or not it's
Okay.
maybe I missed this. So like the bigger number or what you're like, how many you have to select from will always be the first, like will always be in.
The value that's at the beginning is how many you're selecting from. Yes,
And then how many you're going to select.
is the second number. That's exactly right. Yes, Brian.
So how would you have to rearrange the words in that problem to make it a combination?
Oftentimes, it'll actually say when there's some obscurity, it'll say something like when the order doesn't matter. Okay, you'll actually see that occasionally in there, so you'll know it. But we don't have time to do my last one where we talk about it. But well, here's a good one. We can talk about it from this perspective. Okay, let's look at this one, and we will do my hand of cards next time and talk about it for problem 5. Number 4. Julie needs to take 10 electives to fulfill her hours in her degree. She decides to start her career with electives because she's unsure of her major. If no courses have prerequisites of one another, and there are 17 courses Julie is interested in taking, how many different selections of 10 electives can Julie make?
So 17 seats.
Okay, so why is this a combination?
Because there's no prerequisites.
That's part of it. There's no prerequisites. That's important. There's something else, too.
There's
She doesn't have a degree plan. That might be a problem, but that's not a problem for our problem. You might. Do you have time?
there's no required or like never mind.
Okay, you're still dealing with the prerequisites
No.
issue, which is important.
Yeah.
Do you see what it said right here? It said selections of 10 courses. It didn't say how many schedules could she create. Do you see the difference? We're just wanting to know what are you taking, not when are you going to take it? If this asked how many schedules she could create, order would matter, right? It matters. Do you take the 8 a.m. class or do you take the 2 p.m. class? It would be different. It might be different for the professor or the time or the day of the week or the semester. But that's not what this question is asking. This is asking for the selection of courses. That is, when you get to the point where you're looking at the transcript and you see what courses she took, you know in your transcript it doesn't say who your prof was. It certainly doesn't say what time you took the class. So we're interested in this problem in the selection of courses that she gets to use or she has chosen to use. So it is a combination. So the order does not matter. And so Tyler told us a minute ago that makes it a combination. Do you agree? Okay. How many is she selecting from? 17. And how many will she select? 10. Now combinations take a little bit more process to work out because they've got extra stuff in the denominator, right? So what goes in my numerator? 17 factorial. What goes in my denominator? 17 minus 10. What is 17 minus 10? That'd be 7. I'm going to go ahead and write mine in as 7 or I'm probably going to run out of space. There's 17 factorial on top, and then I have the 10 and the 7, which add up to 17. Agreed? On bottom. So I'm going to write my 17 out till I get to what? 10. So 17, 16, 15, 14, 13, 12, 11, and 10 factorial. I'm going to put my 10 factorial at the back just so that it's closer to the 10 factorial I'm going to cancel it with. It doesn't matter where it's located. And then I'm going to put my 7, 6, 5, 4, 3, 2, and 1 at the beginning. All right, my 10 factorials cancel. Somebody tell me something you'd like to see cancel. Okay, so I got 6 and 2 make 12. Someone else. 4 and 16. What will the 16 become? A 4. Good. 7 and 14. And what will the 14 become? A 2. Okay. 5 and 3. 5 times 3 is 15. Is that what you're wanting me to cancel, Alice? Okay, so 5 and the 3 on the bottom both cancel with my 15 combined on top. All right, so let's see what we've got left here. I've got a 17, a 4, a 2, a 13, and an 11. So 17 times 4 times 2 times 13 times 11. What do you get? I have fewer, but I just might have it written down wrong. Can somebody else check for us?
Oh, sorry. Yeah, I didn't show this.
That's okay.
2.
Did you get one, Cheyenne? I have a smaller, 488? I have more than that one.
448.
19. Did somebody get 19? I got 2 19s, and that matches what I have, so I think that's what we should be getting. 19,448.
And
So there are 19,448 different ways that she could have chosen amongst those classes her 10. All right? Too many choices.